instead of making everyone happy, so this will make it a lot more safe. So if you guys would have any thoughts about just doing it. So like this is a lot more safe. So this is going to return this version of the string. So if you're more comfortable doing that version.
You need the case when they're not. It'll run it equal to like all of them.
I have this one.
That's just a zero.
This makes it more.
In theory, that's how it works, right?
Oh, now substrate.
Then now it's looking at position 1, right? Because these two are not equal to each other, right?
No, because then if I substrate,
Now it's probably looking
if I
at
substrate with the
position 1
last
to
one,
position
it'll still, it'll forever check the last one.
now the size is
You know what I'm saying?
yeah, and then they
They
come
can
back
go
here.
before I double check.
Yeah, it'll have to make changes.
Because right there, you move two back because you deleted one.
Yeah, that's like
Three back? Did you guys get it?
So you don't really need to return it, right? You can return it where you're making the calls.
So if you guys did the void version of this function, then congratulations. That's it's pretty easy too. It's just a couple more things you need to watch out for. But I think this is much easier. So anyone have questions going into this? Okay, so we're doing a recursive function. What is the first thing we want to identify? So we want to identify our base case. In this one, they're actually, so what are our base case? Base cases. So, yeah, so if we have a string of length 1, do we need to remove duplicates? No, so there's no possible duplicates, and also for a string of length 0. So those are the trivial ones. So if s dot size is less than or equal to 1, what do we return? What?
S.
Return s. Otherwise, we do like our real stuff. We do like our recursive action. So what is our main? So what are the cases that we have?
Depends on what you want to do.
So for this one, what do we notice?
S dot at 0 is equal to S dot at 1.
Yeah, exactly.
In other words, you're checking if the first two are duplicates or not.
Yeah.
Yeah, so we can guarantee that the string has at least two things because we make this check. So if s at 0 is equal to s at 1, then we definitely have consecutive duplicates. So what do we do?
Well, we did it for the void, so we did S is equal to the substring of 1, 2.
Yeah, we can do that for the void one.
Yeah.
But let's do this for the easier one, and then we can do the void afterwards.
Okay, and the easier one's just to return what you said.
So
Okay.
you would just return the substring.
Yeah, we return a substring of 1.
1 to size. Yeah.
Yeah.
You just do one.
Yeah, this is a shortcut, which means
That'll take from 1 to the end of the string.
Yeah.
Oh,
If you guys know that.
otherwise these are not equal. So what do I do then?
The recursive call.
I'm actually missing a part. So return s dot substring of 1. No, that's not the complete answer. So what do? So what if there's duplicates after SAT1?
Call it recursive.
Yeah, we need call recursive. So call remove, it's like a duplicates on SAT or S substring. And if there's no duplicates, or if these two are not duplicates, what do I do? Well, like, so S at 0 is not equal to S at 1. So that means S at 0 is okay. It's okay to leave in the result. So all we say is, so you guys might not remember this operation, but I can actually concatenate two strings. So concatenate S at 0, or I can say just concatenate a substring from, so substring from 0 to 1, which is the same thing as S at 0. I understand, like these two are equivalent. Plus, and then I need to remove duplicates from the rest of the string. So I just call consent or remove consent dupes at S dot substring. And that's it. Basically.
Yeah, so the trick here is that because it's a recursive function, we still have to reduce our problem every time we reduce case, right? The only thing you're answering here is if they're equal, I have to remove one of them before I reduce. If they're not equal, I keep one of them, which is to add it again to the reduced ones. That's it. All you're deciding is whether you keep the first one or not.
And so one sanity check. Check if for every single case you have, does it either return or does your problem size like decrease somehow? So if it doesn't, then you're going to get infinite recursion, which is not right. So question here?
Yeah. So is S dot substring 1 size minus 1 the same thing as S dot substring 1?
It's the same as S dot substring of
0.
of what is it? S dot size minus 1. It's the same thing. You want to use it?
You guys want to see the void version?
Yeah.
I mean, okay.
I did this one because this is much more clean.
Yeah. See, so the only difference between the void version is that I have to throw this in temp, right? So I have to make something like string temp equals S dot.
But it's not.
Remove consecutive. That's done. Right. So the whole point of that is that string S. Yes. And then remove consecutive substring of that. Right.
String T.
Yeah. This is confusing. Okay, sorry. One more time. String T is equal to S dot substring. And then remove of that. Right? Because the whole point of the void version is that I'm just going to be changing the actual string itself, right? So I make a new one, call it some temp, and then I have to figure out whether that one has its missing parts or not. And then I can set, instead of returning, I have to set here. If that's correct, S. T, otherwise S dot N. Right. So the only thing is that you have to manage this temp variable that gets created every time because you can't return anything, so it's a little messy. That's it. Any questions? So if we're not returning, that's what we have to do. That's the void version with the reference.
is
Make file. Okay. Okay. So we'll go and write up a make file, I guess.
I don't know.
Yeah. Okay, let's write a make file and compile this.
Apparently we're making the Magic TCG game. The program which does that.
What? I was thinking like magic, like doing magic.
Oh, magic card?
Card magic trick card.
I thought you got, never mind. So
What else?
we have a card class apparently, and the declaration class is the cards IH, and we have a magic class. And the magic class is declarative magic IH,
It
and
uses card.
yeah, it uses cards.
And then main uses magic. Does that make sense? Just flow.
Yeah. So I like to think of make files as, so first I have so this is main rule, and these are a list of dependencies. So I like to think of it as, I guess, like a dish, followed by recipes. And then these are the directions to make that dish. But in reality, these are a rule followed by dependencies. And then like the command
Commands to make. Oh, sorry, to make.
to make the rule. So any questions?
Basically, all I make files look like this. Right. This looks familiar. I hope.
So I just like using that analogy. I want to make a certain dish. I need a few recipes to make that dish, and then I follow some directions. Okay, so how do I create this mess? So what I want to do is just compile main.cpp.
In other words, the final product we want is.
The program. So let's call this roll all. We want to make everything. In order to do that, we need what to be main. The object files of main, magic, and cards. Right? And how do we make that into a program? Does anyone remember? Yeah. G++. But we don't want to actually link. So, yeah, all we want to do is link these files together. So we just say G++ main.o magic.o and cards.o. And we just say that this program's name is, I guess, all, or program or something.
So, no, okay, so one of the things is that at the end of all of your commands, whatever this is should be made. So, you know, if this is intended to be an like a final product, like say the program, then you should call the program. Otherwise, if this is supposed to be like a catch-all, then this should actually be something like, you know, all is program, and then program is that.
Okay, right. Yeah.
So the goal of the end of the command is that whatever your rule is, you know, it needs to be created at the end of it. If it's not created, then you're going to cause inconsistencies in your make file. Because if I refer to program and I try to attempt these and I don't create program after all these rules are finished, this is not done, and so your make file is broken.
Okay. And notice, so we have the list of things we need to make. So we need to start off by having a rule to make each one of these. So how do we make main.o?
Make it a target.
So what does main.o depend on? So first off, it actually depends on
Magic.h, cards.h.
so main dot cpp and magic. Magic dot h and magic.
Or you can just put,
Yeah, just h. That will work.
yeah, because these will, you don't even need that because these will be caught by magic.o and and these will be managed by that, so we don't need that.
So wouldn't it be magic.o space next to .cpp?
No, actually.
You could if you wanted to. That just changes the way that these dependencies work.
Okay.
So like if I put in here magic.o, that's saying that, well, in order to make main.o, I need magic.o, right? So I'm gonna have to go make magic.o first. But in reality, magic.o is also needed up here, right?
Yeah.
So
So it'll be redundant.
Okay.
So you don't really need to do that because it's gonna be managed by these three
Okay.
things. So I mean, make files are not unique. You can do it different ways, right? The whole point is that at the end, things you need should be created.
And how do we create an object file? CPP, G++, and then there's a special flag.
Dash O.
Dash C means, so compile only, skip the linking phase. So when I usually call G++, and let's say I try to compile main.cpp, magic.cpp, and cards.cpp in one go, what it's going to do, it's going to compile them separately, then link all of them together. So you guys kind of covered that in the beginning of class, so you guys might not remember so much. But this just says omit the thinking phase. So
Linking.
yeah,
Thinking.
so you need it. And then similar things for magic.h. So this actually depends on magic.h and magic.cpp. Magic.
Yeah. So there's also a couple of things to consider aside from just what is required to make this, right? You have to also think in the list of dependencies, what changes might happen so that I would have to remake this. Because one of the special aspects of the make file is that if there are no changes noted, it will not make it because it assumes that nothing has happened to that object, right? It still exists and there's nothing new about it. So like for instance here, if I wanted to compile magic.o, I should take into account changes to magic.h and magic.cpp, right? Because if the code changes in either of these, I want to recompile this before I pass that back up here and make the entire program. Otherwise, let's say let's say I excluded magic.h for a second, right? That's saying that, well, magic.cpp never changed. So the .h file, I didn't put it in dependencies for some reason. That means if I decided to change the .h file, I wrote a new function or renamed something, it won't take that into account. It'll say, whoa, you never changed that, so this is done. Pass it along, break, right? So these things react to changes in the files, and these react to changes in the targets, which react to changes in the file, which is one big thing.
That's why we kind of made a diagram too. So
Yeah.
And also there's, typically there's a clean option, it's a clean rule, where we just say, no dependencies, just remove all the junk, just leave. So this usually includes all .other files and actual like all target.
And there's no space, right?
This is
There was no space between
this is a separate line.
So yeah,
It goes like this.
yeah, there are no
There's
dependencies.
no dependencies here, that's the point. This is a command under.
Yeah, so between the O and the,
Oh yeah, yeah. So if I put .o, it's gonna try to it's first delete everything inside the current directory. Then it's gonna try and delete something called .o, which probably doesn't exist. Then it's gonna delete program. Yeah.
Delete everything.
So one also little extra thing for make calls is that we can have variables. So usually we use these variables to store our flags. So we can have like an abundance of flags. So flags. So what are some flags like?
Wall,
Dash W, dash W error.
Whatever. And a lot of other things. And what I can do is like this is I can just like I can say replace this with whatever's in there.
That's just like some shortcuts to make coding it up there too. Right? So they can have variables in the column.
So if I, at any time, so if I use this flags variable over here in all these rules, in all these C++ rules, and what if I decide I don't want to use dash wall anymore, then I can just erase dash wall. It's going to propagate the change throughout the rules because it's a variable. Any questions? So is that?
Yeah, for so how many only needs to compile how you're only compiling main.o and actually the part? How come you only have to compile main.o and part?
Because that's all that's needed. So how come we only why we need main.o and part?
Yeah, maybe. Is it that you compile them in a
So no, we're not actually like, so these three get compiled into the final program, right? But in order to get these three, we have to follow these other ones, right? Oh, that should be.
So according to this diagram, we need to make cards dot open because it has no dependency.
Right, yeah.
Magic only depends on cards, so after cards, we make magic. And then we can finally make main. Sorry.
So wait, I actually don't think that matters. You get linked together at the end. It doesn't actually matter.
Does it actually?
No, because yeah, it just says that there's a symbol that exists somewhere else with that, and then it'll link it later on.
Oh yeah. So the result said, okay,
Doesn't even matter.
okay, mistakes all around.
Yeah.
Make all the default to the first one.
So like when you type in make, right, you can also pass in the thing you want to make. So like if you didn't want to make say if you only wanted to make main.o or something, you can just say make main.o. If you want to just type make, then it'll default to the first rule if you want to use it.
Can you say that all again?
So if I say make, right, just that in command line, it will default to the first rule. In this case, all. Right? All will make program and so on. So if I did that, I could just move program to the end if I wanted to. It'll still go and find it because all is the first rule. Right? So I don't have to put program at the end of that case. But if you decided to, or if you decided to put make all at the end of something, then make will actually default to the next one, this one. So you decide to move all these down, make will default to the first main.o. In other words, it keeps going down your file until it hits the first rule it finds, and it makes that one. Now, if you want to give it a specific rule, you can do make all or make main.o, etc. Right? These things make the rule that it's pointing to, rather than the first rule. So if I say make main.o, it'll skip all of these and just jump to main.o. But you don't need to have all and then sorry? Just say all in the beginning. Yeah, so I can just say all in the beginning and how about that? And that makes your life simple.